Lesson 5, we'll continue our discussion of exponents by introducing negative exponents. What exactly does a negative exponent mean? Well, a positive exponent meant that we would multiply the number by itself that many times. 3 times 3 times 3. In this case, that was 27. When we have a negative exponent, what that means is we're going to take its reciprocal. And if you'll remember reciprocals, we can go back to the number 2. And if we take number 2 and we write it as a fraction, it's 2 over 1. What's the reciprocal of 2, or 2 over 1? The reciprocal is 1 over 2. So what's the reciprocal of 3 over 1? Well, it's 1 over 3. So when we take the negative exponent of a base, what we're actually going to do is we're going to take 1 over that base to the positive power it already has. So instead of having a negative 3, when we switch it to the bottom, it gets a positive 3. So let's take one more example so that that's not too confusing. Let's try 7 to the negative 5th. What we wind up with is 1 over 7 to the positive 5th. So we take the negative exponent, we make it positive, and we put it on the bottom. And if you'll remember, this is actually 7 to the negative 5th over 1. So we're taking its reciprocal, and we're making the exponent positive. When we took numbers to the positive exponent, they got much larger very quickly. When we take things to a negative exponent, they get much smaller very quickly. Imagine 1 over 7 to the 5th. That's 1 over 16,807. So that's a pretty small number. So let's put it into practice using some examples. Here we have 4 to the negative 2nd. Remember, we're going to write it as its reciprocal. So we'll take 1 over that 4. And then we'll take the negative 2 and we'll make it positive. So that's 1 over 4 to the 2nd. You could also write it as 1 over 16 in standard form. Take a look at number 2 here. Now we have a coefficient and a variable involved. What's going to change? Well, in this case, we're going to keep the 5, right? Because the b to the negative 3rd, that negative 3 doesn't affect the 5. So we wind up with a 5. And then the b to the negative 3rd is going to be 1 over b to the 3rd. And when I multiply those together, I wind up with 5 over b to the 3rd. Now, what's actually happening is I'm just taking that b and I'm shoving it down into the bottom with a positive exponent. And that's all I would have to do. If I had something like 7x to the negative 2nd, I can simply write that as 7 over x to the 2nd. It's that easy. We don't have to go through this step of multiplying these. Last example. Here we have 4 over 3 times y to the negative 3. If you'll notice, the 4 and the 3 aren't raised to any negative powers. So they're going to stay exactly where they are. What is different is y to the negative 3. What am I going to do there? Well, I know that up here when I had 3 over 1, its reciprocal was 1 over 3. What is the reciprocal of 1 over 3? Well, it's 3 over 1. So it just flips back to the way it was. If it was on the bottom and you take the reciprocal, it moves up to the top. So I'm going to take the reciprocal of 1 over y to the negative 3rd. And that's going to give me y to the 3rd over 1. So let's multiply those two together, y to the 3rd over 1. And I'm going to get 4y to the 3rd over 3. Now, you don't have to go through this step, right? You don't have to do that. You can just recognize that all I'm going to do is take this y to the negative 3rd, and I'm going to take it up. Because it's in the bottom, I'm going to take its reciprocal, it's going to come up and become y to the positive 3 over here. 2 more examples. Here we have 6 over 3 n to the negative 2nd. Looks a lot like our last problem. So we're going to leave the 6 and the 3 alone because they're not raised to any negative or positive powers. But we're going to take that n, and then we're going to take its reciprocal. And that's going to be n to the 2nd in the top. N to the 2nd right there. So we'll wind up with 6 n to the 2nd over 3. But are we done? Can you see something that would make this even simpler? Can we find a way to make this even simpler? Well, if we look at these two numbers, 6 over 3, we know what that is. We know that 6 divided by 3 is actually 2. So we can write this as 2n to the second once we simplify. This is the answer, but this is the simplified version of the answer, and that's what we want. Last one. X to the negative second over y to the negative fourth. What in the world are we going to do? Well, the short answer is we're going to do exactly what we did before. We're going to write our fraction bar, and we're going to take this guy, and we're going to put his reciprocal up on the top with a positive exponent. And then we're going to take this guy, and he's going to move to the bottom with a positive exponent. And so that you can see what that looks like, we actually wind up with the reciprocal of x over negative 2 is 1 over x to the second times the reciprocal of y to the negative 4, which is y to the 4 over 1. And that gives us y to the fourth over x to the second. You don't have to know all of this, but it's a good idea to understand it. This is what you need to know, how to get this from this.